Morning.
Hello everybody, welcome to this chemistry lesson. Today we're going to be focusing on the properties of ionic compounds. The learning objectives. Can I describe 5 physical properties of ionic compounds? And hopefully as well we might be able to explain those physical properties. Okay, the properties we're looking at are typical of all ionic compounds, but the one I'm using today is called sodium chloride. Okay, here it is, sodium chloride. So the first property, the first physical property I'm going to show you is the appearance. Now, sodium chloride is a fairly typical ionic compound, and I'm going to put a few crystals down there. And if I use the hand lens, it might just help a little bit as well. What I'm hoping that you might be able to see is that ionic compounds are often white in colour, and as I said, they are crystals, so they are irregular in shape. Some are rounder than others, some are quite more cuboid in shape, and they also vary in size. They're also quite hard. Okay, so the appearance of ionic compounds is often white and crystalline and hard. Okay, so on your task sheet that will follow, the first property would be the appearance, and I'll be asking you to think of some descriptive words to go with the appearance. Okay, now the second property that I'm going to show you is solubility. I'd like to know, is sodium chloride, is this ionic compound soluble in water? So I've got some water. We'll take some of the ionic compound and we'll stir it in, and we'll find out whether it is soluble. Now, if you think about perhaps last time you were at the beach, you might already know what's going to happen here. Okay, is salt soluble? Is sodium chloride, an ionic compound, soluble? And I hope that you can see down the camera that it is. And you might want to say to yourself, well, how do I know that it's soluble? Well, it's gone, it's disappeared. We can't see it anymore. Doesn't mean it's not there. Okay, you might want to think about, well, where is it? Where does it go? But it is clearly soluble. Okay, so the second property of ionic compounds is that they are soluble, they will dissolve, and what we've now got is an aqueous solution. So this is now a beaker of salt water solution, sodium chloride in water, dissolved in water. Okay, now property 3 is electrical conductivity. Do ionic compounds conduct electricity? So, I've got this electrical circuit ready. If I do this, just to check it's working, hopefully you can see that the numbers change. So let's find out if I put the two, so I'll just do that again, so see there, hopefully the numbers change to prove the circuit's working. Mm-hmm. And if I put these two electrodes into solid sodium chloride, you might be able to see that the reading says 0. Okay, there is no electrical conductivity here. So solid ionic compounds do not conduct electricity. But what about that solution that I created a moment ago? I wonder whether a saltwater solution will conduct electricity. Let's have a look. Again, hopefully you can now see that we do have numbers on the ammeter. So it is clearly conducting electricity because it is in solution. Okay? So, the third physical property we're looking at is, does it conduct electricity when it's a solid, and does it conduct electricity once you turn it into a solution like this? Okay, now the fourth property we're going to look at is brittleness. And again, I'm just going to put some of the crystals onto here, and we'll just see if I can show you that. And I'm going to take the pestle and I'm just going to see whether I'm able to break these crystals. And if you just try to focus on a few, and I'm just going to I'm hoping you can see that it's reasonably easy for me just to give these crystals a little squash from above, and they break into these very, very fine bits. Okay, I'm going to go for it a bit more. And hopefully hear them breaking up. And hopefully now you can see that it's much more powdery, very fine powder. So, sodium chloride, ionic compounds, they are very, very brittle. Okay, does it break easily? And so the final property that I'm going to show you, the physical property, is the melting point. So we've already put some sodium chloride here into an ignition tube, and we're going to see how easily we can get this to melt. Turn this onto a roaring blue flame. Now that ignition tube is designed to withstand very, very high temperatures, okay? So hopefully you might be able to hear something happening as well. Now we know that Bunsen's, especially obviously when they're on a roaring blue flame like this, they can get to incredibly high temperatures. The ignition tube is designed to withstand those sort of temperatures, and hopefully you can see that sodium chloride, those crystals, are still crystals. I'll just take it away and have a closer look. Yep, no sign of melting yet, I don't think. Possibly just beginning now. You might just be able to see that it's just beginning to melt now. But you can imagine the temperature of that. So hopefully you can understand that ionic compounds have got very, very high melting points. Okay, not easy to melt at all, indicating that they must be quite strong. The bonding in them must be very strong in some ways. Okay, so a very high melting point. And I'll show you on the screen one that we tried earlier, and eventually you may be able to see here that this could even happen. It's possible that you may melt the ionic compound, but also the ignition tube itself may melt. That gives you an idea of how hot the temperature needs to get. Okay? So, in summary, ionic compounds, compounds where you're joining a metal with a non-metal, have got 5 physical properties that you need to know about. Firstly, their appearance. They're white, they're crystals, they're hard. Secondly, are they soluble? Yes, they dissolve in water very easily. Thirdly, do they conduct electricity? Yes, when you dissolve them in water first, but they don't conduct electricity when they're solid. Fourthly, they are very brittle. And finally, they have a very high melting point. Okay.